Sound reaching your ears, light hitting your eyes, radio signals, earthquakes, all waves. And every one of them obeys the same small set of rules. This unit gives you those rules: what waves are, how they behave, and what distinguishes one type from another. A progressive wave transfers energy from one place to another without transferring matter. The particles of the medium oscillate about their equilibrium positions. Transverse waves have oscillations perpendicular to the direction of energy transfer. Light, water waves, and all electromagnetic waves are transverse. Longitudinal waves have oscillations parallel to the direction of energy transfer. Sound is the classic example. It travels as compressions and rarefactions through a medium. Amplitude is the maximum displacement from the equilibrium position. Wavelength is the distance between two adjacent points in phase, both measured in meters. Frequency is the number of complete oscillations per second, measured in hertz. Period is the time for one complete oscillation. Frequency and period are reciprocals of each other. The wave equation links them all. Wave speed equals frequency times wavelength. This applies to every wave: sound, light, water, or seismic. The principle of superposition states that when two or more waves meet at a point, the resultant displacement is the vector sum of the individual displacements. Constructive interference occurs when two waves arrive in phase, their crests and troughs align, producing a larger amplitude. Destructive interference occurs when they arrive exactly out of phase and can produce zero amplitude. A stationary wave forms when two identical waves travel in opposite directions and superpose. The result is a pattern of nodes, points of zero displacement, and antinodes, where amplitude is maximum. All electromagnetic waves travel at the same speed in a vacuum, 3 times 10 to the 8 meters per second. They require no medium and can travel through space. The electromagnetic spectrum runs from radio waves at the longest wavelengths, through microwaves, infrared, visible light, ultraviolet, X-rays, to gamma rays at the shortest wavelengths and highest frequencies. Despite their vast range of wavelengths and energies, every part of the spectrum obeys the same wave equation and the same laws of reflection, refraction, and diffraction. The wave equation V equals F lambda ties together everything measurable about a wave. Transverse, or longitudinal, tells you the geometry of the oscillation, but the equation applies to both. Superposition is the reason interference and stationary waves exist at all. When waves overlap, you add displacements. That simple rule produces everything from noise-canceling headphones to standing waves on a guitar string. The electromagnetic spectrum is one family of transverse waves, all sharing the same speed in vacuum. What varies is the wavelength, and with it, the energy, the penetrating power, and the way each type interacts with matter.